Do you know that every object around you is constantly fighting an internal battle? When we stretch a simple helical spring, we aren't just changing its length, we are challenging the material's internal resistance. As we apply an external force, the wire inside the spring experiences normal stress. At the same time, the material undergoes normal strain, which is the physical evidence of that struggles as it deforms from its original shape. Our project explores this delicate balance between force and deformation. So, let's move on to our experiment. These are the apparatus that we need for the experiment. First, we start with helical spring, slotted wicks, hook, thread, ruler, and support stand. These items are very important to help us in order to make our experiment go well. Now, let's watch the experiment in action.
Dr. Kit, we are from Group 2. Today we want to conduct an experiment about stress versus strain curve. Myself, Tami Selvi, daughter of Elongation.
My name is Fatina Dana Aisha.
My name is Sridhar, son of Raja. For this experiment, we are using spring and some loads. First of all, the initial length of the spring is 9 cm. Now I want to add 2 Newton. 2 Newton. Changing length of spring in A meter is 14 cm. Now we are adding 10 Newton to the spring, and the length after the weight is added is 15.5. Is 10 Newton. 12 Newton. And the changing length of the spring is 18 centimeters. Another 2 Newton. So total is 14 Newton. And the changing length of the spring is 20 centimeters. Finally, we will like to add another 2, which total is 16 Newton of the weight, and the change length in the spring is 21.8 centimeters. That's all. Thank you.
Thank you.
Here is the data recorded from our experiment. Looking at the data, we can see the clear relationship between the forces acting on the spring and the resulting deformations. By plotting this measurement, we identified the elastic region where the material behaves predictably and the specific point where it reaches its proportional limit. The results also highlight the material's high ductility as it undergoes a massive change in length without reaching the point of fracture. These calculations confirm how the spring's internal resistance and stiffness change once it is pushed beyond its linear range. In conclusion, our experiment successfully demonstrated the mechanical response of a helical spring under axial loading. While the material showed high ductility and operated consistently within the elastic zone at first, we clearly identified the point where it exceeded its proportional limit. This project has given us a deeper understanding of how internal stress and strain define the integrity of structures we design.